Yeah. This is turned in. Yeah, it's okay. Welcome back, and I'm very pleased and honored to introduce next speaker, my dear colleague from University of Tartu, Professor Jaak Jaagus. He's specialized and studies particularly Baltic Sea Region and high altitudes climate changes, and today he's going to focus on climate change impacts in coastal regions in Estonia. Jaak, floor is yours.
Yes, okay. Can we hear you?
Good morning. I would like to talk about one climate change study in Estonia. I am a natural scientist, so my background is a bit different, and my talk will be also a bit different than the previous ones. Here is an outline of my presentation. First, I give some general statements or suggestions about climate change. Then I introduce our EstKliima project, which is designed for climate change impact studies in my country. Then some data or some figures illustrating recent climate changes in Estonia and future changes, which is projected by the use of general circulation models. And in the last part, I will give some examples illustrating our studies on coastal regions, because we suggest that just the coastal regions are the most vulnerable for climate change in our country. In the introduction, I would like to give some suggestions or statements which are as facts, but sometimes they are forgotten or they are not taken into account. Climate as a climate variable. Climate is a very variable component of nature. Maybe the most variable. So climate has changed in the geological past. Climate changes nowadays, and certainly climate conditions will change in the future. So it is nothing extraordinary. It is a normal, natural state of our environment. The second one is that the climate change itself, or warming by some 2 or 3 degrees, it is not important, I think, for a natural environment and for society. The much more important changes are in extremes, in climate extremes, in changes in frequency of extreme phenomena that could cause much many dangerous consequences. And the third thing that I want to stress to you is that the climate scientists are not agreed in all related things with climate change. So it is not clear that climate will warm in the future. It is expected, but it's not clear that there are a lot of scientists who don't think so. And if we compare the situation about 10 years ago, the number of scientists and their voice is much stronger nowadays, who say that CO2 emission is not the only factor influencing on our climate. So this climate system is very uncertain, and it is not correct to think that it will certainly warm or temperature will increase steadily. It's not so clear. In starting in our studies, some previous knowledge about climate warming in Estonia. Mean air temperature has increased in our country. The Baltic Sea region is one of the regions in the world where the climate warming has been the most intense, especially during the last decades or in the second half of the 20th century. Increase in precipitation has been observed mostly during the cold season in winter. Increase in temperature has been significant in winter and also in spring. These changes in winter are directly caused by changes in atmospheric circulation, large-scale atmospheric circulation, and first of all related to intensification on westerly airflow. The Atlantic influence has increased in the Baltic Sea region, and as a consequence, the winter conditions have changed warmer during the 20th century. And all other main changes, like decrease in snow cover, they are related to this increase in temperature in winter. Last year we started a new project, EstKliima, which is funded by European Regional Development Fund. And here are the main objectives, main directions of our studies, mostly related to different kind of modeling on atmospheric processes, sea ecosystems, coastal processes. So our project is mostly related only on the natural sciences, not on social impacts of climate change. Here is a map of Estonia, and we can see that Estonia is the northernmost country instead of eight Arctic countries. If we take away 8 Arctic countries, in that after that Estonia is the most Nordic countries. And if I thought if we take into account not the northern border of the country but the southern border of the country, the northernmost southern border of the country, in that sense, of course, Iceland is northernmost country. Finland and Norway have also northern border, and Estonia is on the 4th place in that sense. And here are the stations which data we used in our study. We used 20 meteorological stations and mostly used the period 1966 until 2010, the last 45 years, to detect climate changes. During that time, annual mean temperature has increased up to 2 degrees. A statistically significant increase was observed in some months: January, April, July, August, in all seasons except autumn, and of course a statistically significant increase was observed also for annual values. So, here are the changes in mean temperature, which was the highest in January, and the annual mean increase was 1.8 degrees. Changes in maximum temperature, daily maximum temperature, and changes in daily minimum temperature. They are more or less similar, but not in all months. And these graphs illustrate this warming trend during this period. There are 2 stations from Estonia. Vilsandi is the westernmost. It is representing most maritime climate in the coast of the Baltic Sea. And Tartu is in eastern Estonia, located in the most continental, in the area of most continental climate. Figures illustrating changes in seasonal mean values, where seasons are calculated as it is usual in climatology. So summer means June, July, and August, and autumn is September, November, October, November, and so on. So we can see that this general increase has been more or less during every season, but statistically significant it is in this period is only in summer and spring, but not in winter, because climatic variability of temperature in winter is so high, so that this increase in winter mean temperature is not statistically significant during that time. One interesting aspect is described in this figure. Usually, as in IPCC report, as in other studies, it is saying that due to the fact that daily minimum temperature has increased faster than daily maximum temperature, as a consequence, daily temperature range has decreased globally. But in our case, it is not so. During different seasons, these trends in daily temperature range are different. The decrease is typical only for winter, like here for January, but for April and other months of the hot period, this trend is even opposite. In April, this trend is the highest. So daily maximum has increased in our country very significantly, and it increased this. We have also studied named climatic seasons. Climatic seasons are detected according strongly fixed criteria. And in this, for example, summer is a period when daily mean temperature is permanently higher than plus 13 degrees. This criterion works very well in our climatic conditions. And winter means the period with permanent snow cover. Here we can see that the change is described here, so that this inner circle describes climatic seasons, how they were in the beginning of the period, and the outer circle, how they were distributed in the end of this period. And it is put here so that the summer solstice is here in the uppermost, and winter solstice or this Christmas time is below. The conclusion from this figure is that due to general warming, the spring climatic season have moved to the earlier time. So, for example, this late winter means the period of snow melting. It has moved to the much earlier time, and the autumn climatic seasons have moved a bit later, and the summer has lengthened and winter has shortened during this period. Here are figures illustrating how the this wind rose has changed, how the directions of wind how the wind directions have changed. And the highest change is visible here in winter, when the southeastern direction, the frequency of this direction has decreased, and the frequency of, first of all, southwesterly winds has increased. So wind rose has moved from southeast to southwest, and we know that southeasterly winds bring colder air to our region, and southwesterly winds warmer air. So this figure describes quite well the reason or the mechanism how this winter warming has occurred. Changes in precipitation in the Baltic region and in the whole northern Europe are not so clear. Mostly precipitation has increased, how it is shown here also, but the increase during the period from 66 to 2010 was statistically significant only in January and June, but not this annual increase by 80 millimeters is not statistically significant. Snow cover duration has decreased. When we study the coastal processes on the Estonian coast of Estonia, these variables like mean sea level and maximum sea level, they are quite important. Here it is seen that the major increase in sea level has happened during winter. First of all, January, February, and March. Here are two stations, Narva-Jõesuu in the northeastern coast, on the coast of Gulf of Finland, and Ristna in the westernmost coast of Hiiumaa Island. here are different isostatic land uplift, and therefore this increase in mean sea level is higher in the eastern part and lower in the western part. So during the majority of months during a year, there has sea level has decreased due to higher isostatic land uplift. And here are the same changes. Sea ice in the Baltic Sea has a very high variability. Maximum sea ice has changed many times during different winters. Here is a decreasing trend. Here is a jump in the end of 80s, when we remember there were many warm winters, but after that this has stabilized, this curve. Sea ice has formed later and disappeared earlier. It is described here in this figure, and the number of days with sea ice has increased much higher in the western Estonia and lower in the Gulf of Finland. Now I will move to the construction of climate change scenarios. That is also an important part in our project. There are a lot of general circulation model outputs available in IPCC data distribution web page. We used these data for constructing these climate change scenarios. We wanted to have a look how these models predict possible climate changes for the end of this century. Here, in the first step, we had a look how these models describe current climate state. And here are in the Western Estonia, different models are here from different countries, and in the Eastern Estonia. So we can see that this annual range of air temperature is more or less described, but we skipped one model which showed too cold winters in Estonia. This model, this Japanese model, that did not fit to our climate conditions. And the second example, how we excluded the Hadley Center model. Here is a mean temperature curve in black line and baseline, but this model output give very different results for Western Estonia, it is maritime part of Estonia, and for eastern or continental part. So they are completely different climates in neighboring regions. So we concluded that this model output also doesn't fit. And the same figures concerning precipitation. It is well known that climate models do not represent precipitation regime well. So we can see how big differences are. If the mean precipitation curve, annual curve, is in the black line, so practically all the models don't describe this sufficiently well. Not in the western and not in the eastern part of Estonia. So So it causes quite skeptic view to the usefulness and use in these models. Now the modeled results for the end of the 21st century. All the models that were more or less suitable show increase in temperature. First of all, increase in winter, but also in summer temperature up to 20 degrees in Western Estonia and up to more than 20 degrees in Eastern Estonia. Modeled temperature, here they are not temperature but precipitation changes show mostly increase in precipitation in the winter time and the decrease for the summer time. Here are some results concerning the climate change impacts in the coastal zone of Estonia, showing higher storminess, longer ice-free period, higher sea level due to higher wind stress, and as a result, the intensification of coastal processes. I have here some figures illustrating these changes in Estonian coast, but unfortunately my talk is so slow and I cannot show them, but I should skip them. So the main conclusions from my speech are just here. So temperature has increased and wind direction have changed. The precipitation changes are variable and the storminess has increased on the western coast of Estonia. Thank you for your attention.
Thank you, Jaak, for this comprehensive introduction to climate change in Estonia. Questions, please.
This is what you expect when a natural scientist gives a presentation to social scientists. They just go, what?
Yeah, wonderful.
Wonderful.
Jaak, there are pretty similar trends in other Baltic states or in Latvia and Lithuania, or what are differences in terms of climate change according to these basic
concerning temperature, we had a joint study with Latvian and Lithuanian colleagues, and the temperature changes are practically the same. Concerning precipitation, there is a bit difference. The general conclusion concerning precipitation is so that in the northern Europe precipitation has increased and in southern Europe has decreased. So in southern Baltic region, in Poland and in Lithuania, they are in the border. So in some places in Poland there is a decrease, but no, in some cases no changes.
And the increase of precipitation is mainly related to winter season?
Yes. Yes, this decrease mostly is related to summer season.
And if we are talking about adaptation, it means that there are more extremes during summer or vegetation season, and farmers are probably more worried these days than they used to be. decades ago?
We have studied also precipitation increased as well as excessive precipitation as well as droughts. And we can generally say that the frequency of both extremes has increased in Estonia and also in Lithuania, for example.
Yes, question.
Thank you for your presentation. I actually have one quick technical question and then one methodological question. The first is just, I was wondering, you had the different models, and one was baseline, and one was HACM3 and MAR, which I think is maritime, and the other one with the same, but with continental. I think CONT is for continental. What does the first part of that stand for? What is that?
How these are?
Yeah, what does the HACM3 stand for? Because the baseline makes sense to me, but the others don't. Yeah.
Baseline means the actual observed mean values for Estonia, averaged by all stations that we used. General circulation model outputs have calculated for grid points. Grids are different for different models, but for example 5 by 5 degrees grid or so, and I used these grid points which were mostly Estonia has only 2 to 4 grid points which I have used, and I grouped them to the maritime region, which is in the western coast of Estonia, or even out of the territory of Estonia, and continental, which were located on the central or eastern part of Estonia or nearby.
Okay, and the other question I had was in relation to your point that what is most important to consider are the frequencies of the extremes. And I noticed in your charts and graphs you had mean temperature. And I was wondering if, because of your point earlier, if it would be, if you considered it fruitful maybe in a future study to have median measured instead of mean, because of the importance of the frequency of the extremes?
Usually we use mean values for temperature, but I didn't understand exactly what.
I'm just wondering if using median would be considered useful in terms of measuring what you mentioned was important, which was the frequency of extremes. It's my understanding that median would measure that better, but I could be wrong. So I'm asking, your opinion on that.
Yes, median is used when the statistical distribution is not normal distribution. In that case, we should use median values. Some climatic variables are normally distributed, some not. But no, usually we use mean values, averages.
Yeah, I was just wondering, thank you for the presentation, and it seems that there's a huge amount of knowledge available on the climate issues in Estonia. Was wondering about, have these already been applied or used in some kind of societal planning process, and if so, have you, for instance, had a role in interpreting these figures, or in what way have they been maybe used in planning or decision making?
it is difficult to say. All these results, which are published in many publications, they are included into a national report on climate change for our national report. So they are available and well known by wider scientific community. But I am not involved into such planning or practical processes. Maybe Antti can better answer to this question.
Yes, that's really straightforward question, and I can just say that compared to Finland, for example, these climate adaptation policies are more formal, and we are really probably just trying to fulfill obligations on national level and doing all these global processing and procedures and reporting pretty well, but internally, and if we are really talking about some local implementation and adaptation actions in coastline, there are really huge gaps, and even if there are some surveys how to adapt to these extremes, these are just again for formal reasons and not integrated to the local development plans or to local agenda, and in Estonia we are still trying to keep this sustainability discourse, and it's not yet replaced really by climate change discourse or some other dimensions which are coming more and more important.
I can add that in our country it is like in Finland or in Lapland, most of the predicted climate changes have a positive effect for many sectors, for agriculture and even energy consumption and so on. And I think that the coastal zone is the most critical for climate change by many reasons. The increase in storminess, increase in sea level have quite a big influence on coastal zone management in low lying coastal areas. Unfortunately, this risk is not taken into account very much on planning. Of course, we have a 100-meter zone where it's prohibited to build buildings in the coastal area. I think it is the most important restriction.
Thank you very much, Professor Jaagus, and thank you all, our small audience here in this session focusing on climate change impacts in the Baltic Sea region. And I'm really sorry that we missed two other presentations, but instead we had two very interesting stories from Lapland and from Estonia, and we experienced how different these policy making and decision making models could be as well. Thank you very much, and we switch to this panel to conclude what happened during today morning sessions in different streams. Thank you.
are we waiting for the report from the...
Yeah.
Yes, okay.